Hello and welcome back to California Geology. I am Dr. Robert Lopez, and today I want to talk about some of the textures of metamorphic rocks and actually look at some metamorphic rocks. There are two textural changes that accompany metamorphism. The first one is a recrystallization, so the minerals become coarser, and that usually happens in contact metamorphism. A good example is limestone. Limestone is relatively fine grained, and from the limestone, you can make this very coarse grained rock here with big minerals that are also composed of calcite. And this rock happens to be marble. So marble is the metamorphic rock, and the protolith is limestone. So there's a mineral coarsening, a crystalline nature to this rock. This is actually a UC Santa Cruz campus marble. Now, the other thing that happens with metamorphism is this development of a foliation. And so foliation is a preferred alignment of minerals or some sort of fabric in the rock. And so you can have a slaty texture or slaty cleavage where it's very flat, and you'll have, basically the rock slate, a very flat rock, or a very thin slate, often used in blackboards, initial blackboards, pool tables. It's a heavy rock and it's very flat. Or you can have a schistose fabric where you'll be able to see the mineral grains at sand size. So here I see some minerals, and see how shiny? So sand size, a little bit coarser. Note that the slate over here, it's mud size. It's very fine grained, hard to see minerals in that one. So here's our schist here. And then for the gneissic fabric here, we're still going to be in the sand to maybe finer gravel size. But the key thing about this metamorphic rock is that there's these bands, the light and dark. This is a distinctive banding in the rock. Now, how do we develop a foliation? And so what happens is minerals either are going to rotate into that plane of foliation. Note that you have a randomly distributed minerals in this rock. As we apply the differential stress here, we're going to see that the minerals will align. There's another way of doing it here. The other way of doing it is through new metamorphic minerals. New metamorphic minerals grow in the plane of foliation. So new metamorphic minerals grow in plane of foliation. And in fact, if we zoom in this one right here, there are some metamorphic minerals in here that I want to point out. And see, those are little garnet crystals. Those are our little garnets that have grown during metamorphism. So we have the micas here, the white mica, and you can see the fabric here and the minerals that have grown in that plane of foliation right there. So plane of foliation. Let's add that in here. So those are the two ways to develop a foliation. We either get new minerals growing or we rotate existing minerals. Now, in your study questions, I have a chart. And this chart, I'm going to use it here to outline the metamorphic rocks. And note that we have two basic groups. There's a foliated group and the non-foliated group. And so in the non-foliated group, we looked at the marble already, right? For the foliated group, we're going to go slate, phyllite, schist, gneiss, migmatite. These are all, one of the things that's happening, in fact, over here, I just want to show that these are going to be low metamorphic grade, whereas the gneiss is going to be high metamorphic grade, which means the schist is medium grade. So we got medium, high, and this is the highest. In fact, this migmatite, I'll talk more about it in a moment, the highest. This one is almost partially melted. In fact, it's often called a hybrid rock. It's almost verging toward igneous rock, where some of the minerals may have melted, but it still has some metamorphic textures to it. So slate, remember, both slate and phyllite are both going to be mud size. Schist is going to be sand size, and this is also sand and gravel for both of these. We'll put sand, gravel. So you can see there's a little bit of coarsening going on as well, from going from the mud size, sand, to gravel over here, right? So we have coarsening. And then the types of metamorphism, these are always going to be reflected in a regional metamorphism, where there's some proximity to a heat source, like a batholith. Now, in terms of protolith, well, we'll take a shale. A shale will be a good example of a rock that once it goes progressive metamorphism, going from lower to higher grade, it's going to make a metamorphic rock called slate. But if I take that slate a little bit hotter, I'll make phyllite. So slate is an example of something that's metamorphosed to become phyllite. And you can see the trend here. Eventually, a phyllite can be taken to higher metamorphic grade to make schist, and schist can be taken to a higher grade to make gneiss. And then the gneiss can be partially melted here to make the migmatite. So that's our foliated rocks. And just to show you some examples, we showed you the gneiss, right, with the distinctive banding, the schist with the preferred direction in the rock. In fact, this is a mica schist, mica garnet schist. I also have a hornblende schist, and you can see that the minerals, the crystals in here. And if you look carefully, you'll see that there is an alignment on them. In fact, this one's almost starting to form bands, which is getting close to a gneiss, but it's not quite there yet. It doesn't have the distinctive light and dark band. But the key thing is that these minerals all have a preferred direction. There's a foliation in the rock. Now, in terms of the migmatite, I do have one right in here. With this rock, you can see the bands are more contorted. Maybe some of these quartz areas, because remember, quartz melts at a lower temperature. Maybe these were actually melted to make this hybrid rock called a migmatite. Now, for the non-foliated rocks, marble will have a crystal or a crystalline texture. Crystalline. Quartzite is a sandy, just like it's a protolith, which is going to be sandstone. And remember, the protolith of marble is limestone. And then for the hornfells, the texture is basically, we'll say, fine-grained. Fine-grained. And it's very fine-grained. It's black. It almost looks like the basalt, but it's this burned rock. And the protolith is, we'll say, variable. It could be just about anything. And then in terms of metamorphism, remember, hornfells is only contact, whereas these other two can be either regional or contact. So both quartzite and marble can be regional or contact. And remember, serpentinite, we got the peridotite as a protolith, and that's formed by that hydrothermal metamorphism. Let me show you the hornfells here. So you can see it's a black, kind of nondescript rock. Almost looks like basalt, but you'll see no phenocrysts, no crystals in it. So there's our hornfells. Our quartzite, in fact, I have a famous quartzite here. This is you see the little quartz grains in there? Remember, the protolith is a sandstone, but this quartzite, the sand grains are welded together. They're very hard to get apart. This is a very hard rock, quartzite. This famous quartzite is called Johnny quartzite, which documents an interesting chapter in California history. So we'll talk more about this rock, which is found in Death Valley, the Johnny quartzite. And then we've looked at the marble already here, right, with the coarse grains. All right, well, let's stop here, and then we'll continue.